Welcome to the Are You GCSE Physics Ready playlist. This playlist is packed with example questions and guided solutions for every GCSE Physics topic. So it's the perfect tool to help you test your understanding. If you feel like you might need a quick review of this topic before having a go at the questions, or you would just like the ideal revision companion for these videos, then do make sure to download my free GCSE Physics revision notes, linked in the description below. If you're ready, let's dive in.
Okay, so question 1 is explain why fusion is hard to recreate on Earth. So the biggest problem is creating the right conditions for fusion on Earth, because if you try to bring two protons together, which you do when you're bringing together different nuclei, then that's very difficult because they will be repelled by each other. You get this E-static repulsion, as I've written there. And basically, in order to overcome it, you need very high temperatures and very high pressures, which are difficult to create on Earth. Okay, explain how larger elements are made in the stars. So basically, you fuse together larger nuclei than hydrogen. So we often talk about the example of fusing two hydrogen together to create helium, and that's what powers our sun. If you have a larger star, you can fuse together larger nuclei and create the other elements as well. Okie dokie. Fill in the following decay equations, so a bit on the left here. So we've got, this is our decay equation for some fission. So firstly, we've got that uranium 235 92 and something there with it. Well, that is going to have to be a neutron. So I'm going to draw in the symbol for a neutron there, N with a 1 and 0. Because remember, it has to absorb a neutron to become, well, that's my next question mark, to become uranium 236. So still uranium, but it's got that extra neutron now, adding to that mass number, taking it from uranium 235 to 236. Then that splits into smaller nuclei. So we've got some barium, some krypton, and something else. Well, we know that this reaction also releases more neutrons, but I don't know how many neutrons yet. So how can I figure that out? Well, what I can do is I can look at the top line of maths, and I'm going to do it from the uranium 236. So I'm going to ignore that first part where I had my neutron and uranium 235. I'm just going to imagine I've got my uranium 236. So on my left hand side of my top line of maths, I've got 236 equals the 141 from the barium plus 92 from my krypton plus, well, if I do those sums, I get 236 and 233 on my right hand side. So I need an extra 3 there on my top line of maths. Now, as a neutron, as a top line has that number 1, then I would need 3 neutrons to make that extra 3 for my mass number on my right. So that tells me that this reaction releases 3 neutrons. Okay, explain what happens in U235 fission reaction and how it's self-sustaining. So, as we said, uranium 235 absorbs a neutron, becomes uranium 236, which is unstable, so it decays and splits into smaller nuclei, plus a few neutrons, plus releasing some energy. Then those neutrons go on to be absorbed by other uranium 235 atoms, and the whole thing repeats, so you get this chain reaction or this self-sustaining reaction. Okay, what is a moderator and what does it do? So moderator is that part of your reactor core which slows neutrons down so that they can be absorbed more readily by uranium 235. So uranium 235 will only absorb a neutron and become uranium 236 if those neutrons are going slow enough for them to be absorbed. So that's what the moderator helps do. Explain what happens to control rods to deal with surge in demand for electricity. So if there were a surge in demand, I need more energy per second to be released in these reactions. So I would lift my control rods up. Remember, my control rod's job is to absorb neutrons from the reactor, because by absorbing neutrons, they get rid of neutrons that can set off more reactions. So the more they absorb, the fewer neutrons are available for the uranium-235 reaction. So if I lift my control rods up, they absorb fewer neutrons, more available for uranium-235 reaction, more energy released per second. Okay, what are fuel rods made out of? So either uranium-235 or plutonium is another source of fuel as well, in case they ask you. Okay, why do some people think that nuclear power is not justifiable? It is, of course, because the safety and disaster element of nuclear power plants. In the past, we've had nuclear disasters, Chernobyl and Fukushima, that can be devastating for people in that area and for years after as well. So people are very reluctant to have nuclear power stations in their area. How is nuclear power different from other non-renewable resources? So the main difference, I suppose, is that it is clean in the sense it doesn't emit any greenhouse gases, unlike coal, oil, or gas. And you need less fuel, basically. You need a smaller mass of fuel for the same energy released.
Just before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets, and completely for free, so why not?
Okay, so some tips and tricks for this section. Moderator versus control rods and materials. Yeah, so I think the biggest mistake to make is to get moderator and control rods the wrong way round in terms of their use, because moderator sounds like it's doing a similar thing by moderating maybe the reaction. So the important thing is it is your control rods that can really help control your reaction by absorbing neutrons and making that reaction slower, or lifting your control rods up so fewer neutrons absorbed to make that reaction quicker again. And your moderator is just allowing those neutrons to move slowly enough so that they can be absorbed by uranium-235. Okay, your moderator is made from carbon often, and your control rods are made from boron, so they're made from different materials as well. Fusion versus fission, yeah, how to remember it. Fusion, fuse together, so we've got our two nuclei coming together to release energy. Other fuels, yeah, remember you can use plutonium instead of uranium in your fission reaction as well.